Good evening.
Yeah, I think someone has to. I'll take an introduction of yours. I think let's at the moment, everyone, could you please mute yourself? There are some people who still have to mute, I guess. Yes, that works. Okay, so let me give a brief introduction of mine. My name is Vidya. I've been working in Hadoop from year 2009. I have like around 4 years of experience in Hadoop and other big data ecosystem technologies. And I'm a member of Apache as well, Apache Software Foundation. And I'm a commenter of Hadoop and Hive, versioning 1.x and then Hive version 0.9.x. And I'm an ex-member at Yahoo, ex-colleague at Yahoo. I was a part of development of Hadoop 1.x development. And I wrote a couple of books as well on Hadoop or other big data systems, like getting started with Cassandra and machine learning with Spark. So I wrote a couple of books as well in Hadoop ecosystem. And I work with multiple clients across the globe, including like a great retail sector like Walmart, the Home Depot. And if you take telecom sector, I work with AT&T and British Telecom. And if you take healthcare, I work with Merck Laboratories as well as with Abbott Laboratories. And I work with logistics. Right now, currently, I'm working with logistics for FedEx. I'm working. So I work with multiple domains and multiple customers across the globe, and I have some experience, I guess, in big data as well. So that's what a brief introduction about me. I have just 4 years of experience, but I did my education very earlier, 2010. I did my graduation, and I'm a member of Apache in the year 2009, so you can understand from that. And I'm a member of Red Hat Linux Certified as well as Ubuntu commercial versions, because I'm part of a bug fixer over there from year 2006. So I started very early into technical backgrounds. So today, let's see about things. Before going to the session, I would like to take a brief introduction from every one of you one after another. I'll mention you some name and you get there and then introduce yourself. And you tell me exactly what you're expecting from this training, because online trainings are happening totally different, I know. And it's not reaching many of the people's expectations, because Hadoop is absolutely 99% practical. It's totally real time, or else you won't get it anything. Trust me. So let's see what you're expecting from this, and I'll take a little bit of introduction from everyone. Let's start with Nishant Nayak. How are you doing today?
I'm doing great, Vidya. How are you?
I'm doing good. Thank you.
Good. Actually, myself, Nishant, I'm currently working as a quality analyst, and I've been doing this since last 6 to 7 years. And I work with different clients like AT&T, Comcast, American Family Insurance, and currently I'm working in Citizen Insurance. I haven't worked with more of like on the data side. I've been more of like application side QA. But I'm looking for a career shift, so I'm checking out my options. So I came across Hadoop during some searches while searching, and I want to see exactly what Hadoop is, what's the scope, how's the market about that. Just wanted to see, check out my options before exactly taking my decision on what should be my next career move.
Yep. Okay. Thanks for that. I'll answer your question. I'll make a list of that. I'll answer your questions one after another. Yeah.
Sure.
Yep. Thanks for your introduction. And let's go to Prem. Prem Bernard. Could you please introduce yourself and let me know what you're expecting from me?
Hey, this is Prem. So I work in wireless industry. I'm a principal engineer right now. Just trying to get into a career change to see how big data is going to go with me. So yeah, that was pretty much it.
Okay. Hello.
Yeah, that's pretty much it. As I said, I mean, I'm just looking into moving to Hadoop from a wireless sector. Currently, I'm a principal product engineer in a wireless industry. Just trying to get into the big data to go in, and then just want to jump in the wagon. And it's going to be the big thing for the next few years. So.
Okay. Okay. Cool. Thanks. I'll answer your question as well. And let's go to. Thanks for the introduction. Let's go to Saravanan. How are you doing today? This morning. Saravanan, you there? Hello? Can you hear me? Hello? Hello?
Hello.
Okay. Yeah, is Saravanan is there?
Okay, I'm his wife speaking, Anu Saravanan. Actually, I was about to take the sample program.
Okay.
I'm good. I'm glad I'm able to take this program sample class now. I'm a graduate in IT. I have no work experience. I just came across our Hadoop, and I thought I don't know how far I'd be able to get into it, and I should just. That's why I just want to see the sample class.
Okay. Okay. Thanks for the introduction.
Thank you.
I'll answer your question. Yeah. And yeah, let's move forward. And Tasfiq, right? Tasfiq, you there? Hello, Tasfiq. Yes. You can speak out. You can speak out. Okay, but your mic is muted. Let me check. Okay. Could Satish, if you're there, could you please unmute him so that he can talk about?
Yes, it's unmuted.
Okay, meanwhile, let's go to Yadagiri.
Yadagiri, yeah.
Yeah, Yadagiri. So what are you expecting from this? Hello, can you hear me? Hello?
Hello.
Yeah.
Hi, how are you doing?
I'm doing good. How are you doing?
Yeah, this is Tashfik.
Yeah. So what are you expecting
Yeah,
from
fine,
us?
thank you.
Yeah.
Yeah, I have already learned the Oracle, and as I am listening from everyone, Hadoop will be the next big thing. So I just want to know about it, and let's see I can change my career or not to Hadoop.
Okay. 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 Thanks for that. So thanks for your introduction. Yadagiri, you there?
Yeah. Hi, Vijay. Yeah, I have been working
doing?
in Oracle PL. Yeah, doing good. I have been working in Oracle PL SQL background and working for project and portfolio management domain. So I'm thinking to learn new technologies. So thought of doing this data analysis and checking for the new technologies. Yeah.
Okay. Okay. Thanks for that. So thanks for your introduction. So let me take over, and then let me let me tell you what this technology is and how the things are running out there. Yes, there are many questions that is Big Data is going to be reach out all the expectations, and then can it cross the current existing RDBMSs or data warehouses or some other opportunities what we have here, like, Hadoop is totally a different framework. It's absolutely a total different framework. You can't compare with your database. Of course, you have your database advantages as well. You cannot completely replace your RDBMS with Hadoop as well. So it works in major cases like if you have large data, or you need you have lots of varieties of data, and if you want to something like do which is doing more veracity kind of the issues, then it is going to fit in there. And of course, big data has a great advantage in any of the domain you can pick, like retail, healthcare, oil and gas, or telecommunications, or else logistics. What are the domain you pick? Financials. So what are the domain you pick? Hadoop has greater future. And can Hadoop alone handle this? No, that's totally a myth. Hadoop alone cannot handle this. Hadoop has like around 117 technologies as of now today in Apache Foundation, and 60 more plus technologies are releasing this year, by end of this year. So you have like around 170, 180 technologies, and you don't know which one to pick. Whenever you talk about Hadoop, most people say, yeah, it's big, it's just MapReduce, it's just Hive, it's just some NoSQL, Cassandra, HBase, that's it. But many people don't know that how do we apply and how do we get ROI of it, because it's totally different from your entire it's totally different from the existing ecosystem. It's entirely different. It depends on your in-memory technologies, and it depends on the technologies or the ecosystem components what you pick, and which scenario you're using Hadoop. There are lots of questions around. Yes, but there is absolutely no doubt in saying that Hadoop is a great technology, and it's an emerging technology. Sorry, because it started in the year 2004. So just now, right, these days people started working on it. It started development in 2004 and applying in productions from 2006. It is an older technology. It's not a new technology. And yes, it has a great future till next 20 years. 20 years, you can say simply. But that's what I told. Alone Hadoop cannot take anything. You have to add some more components with Hadoop. As I told, like you have around 180 by end of this year. So with Hadoop, you can use any of these 180 components and then apply it to your ecosystems, and you can solve your data problems. So let me take you through what are the different concepts that I'm going to cover you today. So today in this demo session, I would like to more concentrate on Hadoop core concepts, like something like what is Hadoop and why we need Hadoop, in what scenario this technology has emerged, and Hadoop ecosystem, what are the different components, some example components that are working with Hadoop ecosystem, how usually a Hadoop ecosystem looks like, and some practical problem solving with how do we solve the problems with Hive, Big, and HBase, some other components of friends of Hadoop, you can say, that can work together with Hadoop, and applications of Hadoop. So different applications, how we build on Hadoop, and what are the different goals that you have to reach if you're building an application over Hadoop. And if you have any questions, I'm going to answer them at the end of this. Okay, so let's go to very older days. Let's take some year of 1990 or around. So in 1990, if you have some data and you want to analyze some data, means what do? You pick some RDBMS, and where your data is totally structured, kind of a tabular format, and you insert your data inside that RDBMS, maybe Oracle, SQL Server, whatever it is. And you write some queries over that, and then you analyze it. You use it for OLTP as well, online transaction processing. You apply some triggers, views, lots of things. So what happened there is, when we talk about storage media, database is actually a storage media, where we store our data and then where we retrieve our data for any application. So usually from where this data is getting generated. So let's take any web application. Web application, very basic concept, I guess, which has basically a 3-tier or 2-tier kind of architecture, like a middle tier, a backend, and then a UI. So UI is where you give some input and you request for something, reaches your middle tier, as well as it goes to backend, process your request, gives a response back to middle tier, and then middle tier response back to your front end UI. It could be any like HTML5, Java, and then Oracle, a simple web application. So how do we generate data? How the data is generating here? So usually internet scale generates lots of data. Let's take, for example, Yahoo. Yahoo is the most visited site on the internet. It has like around 600 million plus unique visitors per month. It has like around billions of page views per day, billions of searches per month, billions of emails per month, IMs, address books, buddy lists, and weather detail, games, horoscopes, news, messenger, mobile, as well as some cricket scores, lots of data. So usually we get 680 terabytes per day at Yahoo, only just by your entire Yahoo web applications, a combination of entire Yahoo web applications. So So usually this application generate data, like let's say they generate the customer data, the users data, and some, if you're talking about stock markets, the stock market data, and it generate every application data. So that means the log files and searching indexes, these kind of things, you start collecting a lot, and then it gives you lots of data. So what is this big data basically? Big data is nothing but a large scale of data, that's it. Nothing like a new technology, nothing like that. It's as it by name, we can tell that it's a large amount of data. So with this web applications, we generate lots of data. And what we are going to use with that? So how we are going to use this data? So what is data basically? So data is nothing but some information, right? So let's take some example like a table. A table has like around 4 legs. It can move, it cannot move, and it is in so-and-so color, and it has some drawer where you can keep your items. These are all the information. So when you talk about application data, it has all this data, like it has log data. Okay, so these many users are coming to your application, and what are the different types of customers you are looking in, and what are the different types of data that you are inputting to your web application. So there are lots of information. So how do we retrieve business value from this application? How a company like Yahoo can retrieve business value from your information or from the data whatever they're saving. So let's see very one simple example. I'm not talking in much complex terms. So as you know, there use an advertisement or kind of a information what you're looking, something like an article like this or a deck like this. So the first part is called a search marketing part, whereas you input your data, and then once you input your data, you get your articles. That's lots of stuff, and as well as on the right hand side, sometimes you'll get some advertisements as well. So you'll get lots of ads as well. So in these ads, so you will see and you can click on some ads. There are lots of things happening inside. Users usually browse. So what inside Yahoo, what we do is we apply some query patterns over this data, like how many users are coming totally to our web application, and from which geographical locations across the globe are coming in here, and what are the most pages that they are looking for, and how we improve some performance of some page. So this kind of usual query patterning we do with the web application at Yahoo. So we have lots of data here. We apply some query patterns over the data, and then we see, okay, these are the most important pages, and these are most viewed pages by your customers or the users. Then what else we can do on that? So the next thing we go is contextual advertising. So then we track down to every user, and then we see that, okay, what a user is doing in short term as well as long term. Let's say if you have some Facebook account, if a user is logging out there, and then he's just in there for a couple of minutes, what he's doing? He's just updating his status, and then he left out the Facebook. And if a user is staying for a longer period in a Facebook application, what he's doing? He's basically doing, let's say, chatting. Chatting usually he does keep on. That's an hourly. So it takes hours. So what a user is doing and which geographical data he is from. So we combine that. Okay, US people, they mostly don't stick to Facebook. They just come in there and then they update the status and then they leave. And UK people, yes, they come in there and then they keep on chatting for longer times. And India people, they keep on uploading the pictures. So we selected what kind of people are looking for what kind of information, so that we can deliver the best to the best users according to the geographical locations. So we get the data from basically what the user doing, and we apply some patterns over the data, and then we track down the user behavior of the application with this geographical data as well, and then find out that, okay, this is the user is most looking for, and these people are using these kind of functionalities very well. And now we have to connect right people to the right content. So what we do is then we build a model for the page view. Okay, these pages are most viewed pages. Then we build a model for that, and then we personalize these pages according to the things that a customer or a user is looking for. And then once a customer feels that ease or feels that comfort whatever he's looking for at his hands. So that makes him to increase more engaged with the application, which helps to grow your web application standards like anything, and which helps to grow your traffic to your website a lot. So if people are coming a lot more, they keep on clicking these advertisements and those particular pages which are most relevant pages, and that's how you get revenue from your company. So once you start getting revenue from your company, the business value per company keeps on going. So this is how one simple application that tells you, yes, you have to save your data and you have to know what people are doing at your web application or some application of your domain, and you have to understand what people are doing. You have to see, okay, yes, these people are doing this and these people are looking for this, and you build you customize your application like that. It helps user to get engaged with the application much more easier, which automatically brings you more customers in. That's how Facebook has grown, or that's how Google search engine has grown. So there are lots of more people coming in. They started reporting lots of data, and then we check out the data. Okay, this is what people are looking for. This is what that continuous process can keep going on for like longer periods. Maybe it could be like 10 years, or maybe it could be like 20 years also. So it's a continuous processing, and the data size keeps on growing because they keep inputting the data a lot, and you have to keep on analyzing your data every time, and entire data you have to analyze. So these things usually generate big data. So there is a saying that till year 2000, whatever the data is, from 2000 to 2014, the data has been 20 times increased. So you can understand from that, data explosion is happening like anything. People started working with multiple different types of data. Like it could be like a tabular format it begin with. Then later people are looking for, okay, every time I retrieve data from my application, to keep it secure, I convert into JSON in middleware, JSON data, JavaScript object notation data, which just for security purposes. And then again, I started taking data from databases like an XML. So every time you have to convert this data from JSON to textual or tabular data to a JSON data or a WebXML data. So that is going to be again hiccup, because it's going to need you some processing. But when you're working with some petabytes or terabytes data, the processing really matters. Even if it's a second late, that really matters. So then the types of varieties of data inputs has been changed. Like you have to able to save directly your data as a JSON data, directly your data as an XML data. You have to able to save your data, let's say some images. If you drag and drop some image in Google search engine, it automatically gives you the similar or the most related images with the images you have input. So this image processing will come soon. So that means you have different varieties of data. Tabular, maybe it could be like XLS history, or else it could be like a JSON, XML, semi-structured data, and then you have unstructured data like something like images or MPEG-4 or MPEG or MP4 video files, where you do convert your data to binary format, and then binary format to human readable format, and then you analyze your data, and then yes, these pictures are belong to one category, and these pictures are belong to one category. So there are lots of varieties of data, and then the scale of the data is growing like anything. And we need velocity, of course, because if you search for something, you need to get back your results in meantime. If you search for something in Google, you have to get back your results in maximum less than 1 minute, 1 second. 1 second is a very big time over here. If your Google gives you your results back in half an hour, no one is going to use Google. So we need velocity. We have lots of varieties of data, and we have volume of the data is very high. And there's one more factor called veracity. Even with a different variety of your data, you need to bring the velocity. So all these 4 factors generates big data and some hiccups with your existing ecosystems, because you cannot directly store images or something in your databases as of now, I guess. So these things generally generate lots of data and then lots of varieties of data, which your RDBMS is not capable of. So I just talked about internet scale companies like Yahoo or Google or Facebook. They're internet companies. They generate data with internet. But is this big data really generating at internet companies? No, there are other companies, other domains as well which generates this big data. Let's take for example Walmart. I worked with Walmart a year, and in the year 2012 I worked with Walmart. So there are 267 million items selling across 6,000 stores per day at Walmart stores in US, and they got like around 4 petabyte. So let's say if you want to keep some offer of 10% off on some item on some particular store in some category, what is the profit or loss that you're gaining? You can calculate by sitting today, and you can roll out that offer sometime in next week or the other. So you have to understand the supply chain, you have to understand market trends, you have to understand how pricing strategy, what percentage of off I can keep, like 10%, 20% off, free deliveries, these kind of different pricing strategies, what kind of things I have to apply. So Walmart even generates lots of data, because 267 million items means that's not a simple thing to handle as a retail or a supply chain ecosystem. So if you have 4 petabyte, again, it's a data warehouse, means it's a single point of failure, again, single point of a standalone ecosystem. If your data warehouse or database crashed, that's it, you're lost. And every time you keep backupping your data every day, sometime in midnight, and then your database is crashed, something you immediately replace or restore the data with your backup. So that's what keeps on going from, this processes keep on going from past 10 to almost 15 years, I guess. Then, okay, Walmart is totally a retail chain. Then what about the remaining things? The Sloan's digital skyscraper, it's like something like you can say capturing the celestial objects. Celestial object is nothing but if you look at through Google Maps or something, or from some other planet, the things on Earth will look like an object. That's called a celestial object. So every day we are capturing like around 200 GB image data per day, and one data set is like around 10 TB, 287 million objects. So with SQL Access we can't do this, because you store in some physical paths, and that path is going to store in your table columns. That's it. You're not going to store your data directly in your database. That's how we work with blob and cloud storages of RDBMS or data warehouses. So this, we keep on getting some problems, like how to do this. Let's say let's talk about some capabilities of RDBMS or data warehouse what we have today. So let's take an example of SQL Server. SQL Server has like around a capability called as, if you have like around 7 billion records, it takes time to like around 45 to 48 minutes. That's quite a big time, because RDBMS has the capability to OLTP and then OLAP. So if you're looking at all online transaction processing, if you want to query 7 billion records, which takes around like 45 or 48 minutes, no one is going to wait for your application. Your application is going to be a failure. So how to process this big data? With existing ecosystem, it's totally different, and what with this distributed computing. So let's say you have a large data set which is greater than like around 100 terabytes. To read this 100 terabyte, it takes 11 days on a standard computer. And it takes a day across if you have your internet, or if you have your local bandwidth solution as 10 Gbps, which we call it as a 10 gig internet. So 10 gig Ethernet is not that easy. I think NASA worked with recently 100 gig Ethernet. So we are not NASA. You don't get 10 gigs. So that's totally different. So 11 days, who is going to wait for open a data set that just 100 terabyte? Because we have seen lots of data like 7 petabyte, 10 petabyte. I work with 40 petabyte also. So how to do this? So with Hadoop or this big data technologies, on a single node with just 50 Mbps speed, we can retrieve within 23 days. On a 1000 node cluster, it takes like around 33 minutes. So what is a cluster? A cluster is nothing but a group of machines that work together. A node is nothing but a machine, a PC you can say. So if you keep on increasing your nodes in your cluster, like let's say 10,000, it might reduce to 3 minutes. Okay, 50,000, maybe 3 seconds. Then let's say 60,000, maybe 0.3 seconds. So 3 milliseconds. So this is how usually things will work. Because let's talk about some old scenario, which is like in 1960s or 1970s. You have some wooden log, some big wooden log. To carry this wooden log, what we use is we use ox, right? So ox is to carry this big wooden log. If the size of the big wooden log is increasing like anything, we haven't looked after for bigger ecosystem. Nothing but we haven't looked after for bigger ox. Instead, we added one more oxen to that. So 2 oxen can carry this load. So that's what this big data processing is. The secret behind this big data processing is distributed computing. Your work is going to get distributed across all your nodes in your cluster, and process your data together, and then it gives back your results in meantime. So does it mean that if I have like around 1 petabyte data, if I have like a 1 lakh node cluster, can you give it me in like 0.2 seconds? No. Big data technologies, some technologies have that capability, but some technologies still doesn't have that capability. Even Hadoop doesn't have that capability to give your data back in real-time systems. So let's say, so many things that we faced so far with existing ecosystems. Let's say, because moving data from the storage clusters to computation clusters is not that easy. Let's say you have 400 terabyte of your data and you want to move your backup data to some other production data, or production data to some other staging data, 400 terabyte. It's not that easy. 400 terabyte, you have to build higher network bandwidth, and you have to put lots of data communication you have to solve. And your programmer always worries because, oh, dude, I just kept like around 400 terabyte data from a production cluster to a staging cluster, and I don't know when it's going to copy. And let's say, yes, okay, finally it got copied somehow. After it get copied, you have to understand, is this the right data I copied or not? So you have to check with your data validation. That's not that easy on 400 terabyte, because reading 100 terabyte on a standard computer takes like around 20 days. So who is going to wait for that? That means 400 terabyte means 4 into 23. It costs like 3 months. Who is going to wait for 3 months? So traditional debugging, traditional performance tools, or these kind of things don't apply here. And you expect failures a lot, because failures expected rather than exceptional. In every clusters or in every ecosystem, the computers fail every day. And you will find problems like data corruption or data loss, or some computation values are going to change. So lots of things happens if your data size is growing like that. So how to, and it takes very expensive to build reliability into these kind of applications, because you have to invest a lot. Your network bandwidth has to be higher, and you have to use higher storages like hard disks, or you can use higher GB like 256 GB RAMs, 512 GB RAMs, or some 24 core processors. And this kind of lots of investment you have to do to handle such a big application. So we thought like, hey, we need something common infrastructure and a standard set of tools which can handle this complexity. And we need some technologies which is efficient so that it can handle all of this and scalable. Even if you scale your size of your data from like, let's say 100 terabyte to 1 petabyte, your application has to run at the same speed when it is running at 100 terabyte and when it is running at same petabyte. Both application speed has to be the same. You don't have to, a customer or a user doesn't have to know that yes, it is running with a bigger size or it is not running with a smaller size. The application is running fine. And of course, faults will happen everywhere, as I told you. But how easily are you going to solve your faults or errors that are happening across big data ecosystem? And you need some tool which is very easy to use. I don't want something like Greek and Latin to learn. I want something like which I'm already familiar, because 20 years it took me to build SQL, and then again 5 more years took me to build a data warehouse like Informatica, Teradata, Vertica. So, and then I have my own programming languages, Java, some .NET, some scripting languages like Perl, Python, Ruby on Rails, and then you have lots of technology keep on. I'm already familiar with this. I don't want to learn one more new thing. So these kind of things brought us all to a single point called Hadoop. So Hadoop is one of the big data technologies that we are using these days very rapidly. And what is Hadoop? Hadoop is basically a massively scalable, queryable store and archival. That means massively scalable. It can scale up to any amount of the data. It works easily just like you have with your lower data size and you have with your peak data size. And it's a queryable store. You can query your data store like anything, just like how you do with your SQL and Oracle. It's nothing more. And it does archival as well. You don't have to back up every day. So how we do in existing ecosystem is we keep backups for last 15 or 20 days. If your application size is 100 terabyte and you keep your entire data backups for last 15 days, that means 15 into 100. Are you going to keep like around 1 terabyte? No, we are not going to keep 1 terabyte. So you don't need to do backups. The actual application size has to remain the same or else a little more, but not like this in this worst scenario. So Hadoop has a great capability. So we have one more concept here, like file system. So where do we store your data usually? We have very basic concepts I'm going to touch, which you might know, you might not know. Usually when you save your data, like let's say abc.txt file in your operating system, like c/some user/document/abc.txt file. So where it is going to save your data? It's going to save your data in your hard disk. Okay. In my hard disk, how is it going to save? It's going to save in your blocks of your hard disk. That's called file system of your hard disk. A file system is something like in Windows you see like NTFS and FAT32 when you're formatting your pen drives, and it will be something like ext3 and ext4 if you're using Linux operating systems. So the file system has this capability to store your data. Okay, and how come your operating system is going to retrieve that? Because when you store your data in your file system, it doesn't know what it is. Only the operating system knows what it is. So when you say, let's say abc.txt in some location to the operating system divides that file into 128 KB blocks, and then it's going to save in your file system. And when you are opening this abc.txt is in your operating system, and the operating system knows which are the 128 KB blocks that are related to abc.txt file, and it reads those blocks and then it gives you back the data. So that's what the concept of file system. Even if you store in your database, it does the same like that. In your database, if you're storing data in some table, means it contacts to your operating system, and then operating system is going to store your data in your file system. So when you're opening some table, it contacts your operating system, and then operating system is going to read blocks from your file system, and then it gives back your data. So lots of processes involved. Let's say if I'm saving 1 terabyte file, you have some millions of blocks of 128 KB each in your file system. So that's why when you're trying to open a 5 MB notepad file in your machine, it keeps on loading. That means it is accessing the disk. Nothing but it is accessing the file system. The time taken to access the file system is increasing. That's what we call disk seek time. So the disk seek time is getting more higher when you keep on increasing your data sizes, which obviously makes your application run slow. So this is the file system concept basically, and Hadoop has its own file system which gives you data with higher bandwidth speed. It's not like your existing NTFS or a FAT32. It's something, a new file system which has greater bandwidth, like around Gbps or TBps even you can see. I've seen like around 4 TBps in Hadoop systems while reading the data from Hadoop file system. So file system plays very key role in retrieving data here. And you have a set of queryable databases and data warehouses as well. Okay, how do I retrieve the data? I already aware of SQL or something else or Oracle. How do I retrieve this data? Okay, you don't need to worry about that. You don't need to learn something new. If you know SQL, we have a SQL interface over here for Hadoop where you can write your queries just like in your SQL fashion, and then you can get back to it. So that's easier. And it also does archival store. It automatically backups your data. So every file you copy inside Hadoop file system, it makes 3 copies of that. So across the nodes. Again, Hadoop is a distributed computing technology. So it keeps across all your cluster. Even if one system goes down, other 2 backups you have, you are going to run with that. But not more than 3. I haven't seen more than 3. So if you have 100 terabyte of data, you're going to store 300 terabyte. That's it. Not like 15 days backup. And open data format. So as I told you earlier, databases can only handle with structured or semi-structured, that too with some missing values you can handle. But Hadoop has greater edge to save your data, like in tabular format, XLS, CSV, or else in images format you can save directly in JSON formats, you can save in HTML formats, you can save in XML formats, you can save with any open data format. No or doubt at all, Hadoop can retrieve it in much faster intervals. And it works efficiently with all these data formats as well. And it allows flexible schema. So if you are going to design a database architecture for your application, which will take like around a month or a couple of months, and then we design a bigger architecture, and later after like 1 or 2 years you want to change few things. Are you going to change your architecture? No, I don't think so. You do some modifications, but not your entire architecture change. You're never going to touch with that, because that's a serious problem. Let's say there is one more column you're going to add to one table which has like around 10 billion records. And let's say it's very simple table like students table we have, and we are going to add one more column called as ranking. You have like around 10 billion records in that. At the initial stages, I told like, okay, let's keep the rank as integer value. Okay, fine. We'll give input as integer value like 1, 2, 3, 4, 5, like that, 10 billion. And tomorrow your students base is increasing like anything. From 10 billion you move to 100 billion. So almost like 10 lakh people are already getting same value like 4th rank, 4th rank, 4th rank, 4th rank, like that. So how do you decide these values? Then I thought like, okay, let me change my column data type to float types. Okay, then you are going to save as 1.1, 1.2 like this. Then to retrieve much more accurate values basically. And today some other day you tell that, okay, our customer base has increased from 100 billion to 200 billion. So now even float is not accepting us. What do we do? Okay, let's change it to string. So the real hiccup is, if I try to retrieve day before yesterday's data, it has to give me in integers. If I try to retrieve yesterday's data, it has to give me in float. If I try to retrieve today's data, it has to give me strings. This is literally not at all possible if you're using a SQL. You can save only one data format or one data type to one column in tables, but not multiple data types to a single. So that's not possible. Of course, we can cast it, but at this point, cast doesn't work at all. So you cannot change your architecture if you're using RDBMS or data warehouses. But in Hadoop, you can change your schema at any point of time. You don't have to worry about that. NoSQL will take care of that, absolutely. And fault tolerance, of course, fault will happen here also, but you can either rectify or you can handle them much more easily. Hadoop framework gives that easiness to you. And never delete the data, because data is information what you have, and it's a business value where we are going to get from the data. So data is very important. So never delete the data. So all these factors retrieve us to a one data component called as Hadoop. So Hadoop is basically a distributed framework, basically for two purposes. One is processing your data as well as storing your data on basically a commodity hardware. You don't need something like SAN clusters. You don't need like bigger machines. You can store in Hadoop clusters, which is much more hardware-wise. It's much cheaper when you compare to SAN, because SAN is a single big ecosystem. If some part of SAN goes down, entire you have to replace your SAN with a new SAN, or else you have to repair it, and you have to wait for some time. But Hadoop is not like that. Hadoop is a distributing processing framework where multiple systems work together. So even if a single system crash downs or corrupts, it's easier because you have already backups in other ecosystems, other machines in your cluster, and then you can run the application just like before. Nothing change is going to happen there. So it's a distributed framework, and it's completely open source. So you have to. It's not commercial purpose. Like it's not commercial like professional. You have to pay something like that. Nothing like that here. It's absolutely open source, and you can download it free from Apache website at hadoop.apache.org. And it's written in Java because, as I told earlier, I don't want to learn something new. I want to implement which I already know. So it's written in Java, and it runs on different flavors like Linux, macOS, Windows, Solaris. And mostly in production systems, we use CentOS operating system now, most of the things. And client applications can be written in various languages. Your Hadoop application can be written in any open source language. If you know Java, yes, you can write it in Java. If you know Perl, yes, you can write it in Perl. If you know SQL, yes, we have Hive for that purpose. You can write in your Hive. And yes, I don't know anything of here because I'm very new. I don't know programming language. I don't know a scripting language. I don't know some SQL kind of language. I don't know anything. So what I have to do? Yes, we have other options like Scala, which is very easier programming language these days. And you have Pig, data flow level language. In fact, Pig is much efficient than regular other types of jobs in Hadoop, because in Pig you can write 100 lines of Java code in maximum like 20 lines. So which helps you to increase your productivity like anything. You can develop bigger problems, or you can solve bigger problems in much lesser time with the same effective solutions as well. So that's what advantage you got here. You can write in various languages. You don't have to worry that, yes, I don't know Java, can I learn big data? Yes, you can learn, because Hadoop not only runs with Java, it runs with lots of other components as well. And latest version of Hadoop release is 2.3.x, I guess, these days going on. So that's what Hadoop. So what are the features of Hadoop? It is scalable. Yes, in Hadoop, as I told earlier, it has basically two types of things. It has data processing capability. It has data storing capability. Yes, in Hadoop you can store and process petabytes of data just by adding your hardware. Okay, today your application size is some 100 gigabyte. Tomorrow it may reach up to 120 or 140. Okay, don't worry. Add a couple of nodes to your cluster of 100 TB. That's it. You're done. You don't have to worry. You don't have to stop your cluster. You don't have to do anything. Just add more hardware. That's it. And anyway, it's a commodity hardware. You don't need to invest much investment over there. And it's economical, because if it's like a SAN kind of ecosystem, if the system fails, the entire system is going to drop off. And it costs a lot economically. But here in Hadoop, as it's a distributing technology running with a commodity machine, even if one machine goes down maximum, you're going to lose like $100. But whereas SAN, you're going to lose like 10 grand or 20 grand like that. So thousands of commodity machines work together and then performs your task. And it's efficient. Run the task where your data is located. You don't have to copy data from one cluster to another clusters. You can directly run your task where the data is exactly located, and then you can get back the results. It's not like data is going to move. It's like task is going to move. So no data movement here. And reliable. In earlier existing ecosystems, we have to back up data every time, right? But here we have a factor called as a replication factor, which automatically backs up your data with the 3 times by defaultly. So you don't need to worry about the backupping of your data. If some data is lost, means no, it never lost, because you have other backups available in your ecosystem. And it has, this Hadoop framework has greater capabilities to rerun the tasks if they're failed. So in your SQL or something, if your query is failed, that's it, you're done. Again, you have to run it on your own. If some view or trigger is running, in between the running of some trigger, some exception came, and then that's it, the job is stopped. Someone have to go in there manually, and then you have to rerun it. But here, Hadoop, one of the components of Hadoop has that capability to automatically run the job. And even if some task is failed, the other automatically picks up and then it runs the task for you on other copy of the data. And Hadoop is majorly used for batch data processing. It is not recommended for real-time or user-facing application. But there is one application, I think, couple of applications so far in today's world, where we are using Hadoop at real-time or user-facing applications. The first one is your Facebook chat application. Facebook chat is the first online real-time user-facing application that runs on Hadoop with some other components of Hadoop, of course. Alone Hadoop cannot do that. So what are the different kinds of applications that you run over Hadoop? Yes. So let me take a brief overview what I've told you just a few minutes back. Yes, we understood from where we generate the data, and we understood how to process this data, and that's where we moved to distributing computing technologies. And then from there we understood what are the today's existing ecosystem problems and how we are going to solve that, what are the different main features that you're looking for. Then we came into Hadoop. Then for Hadoop, I told like this is what the Hadoop is, and it has these many features. And what kind of applications? So how where Hadoop you can use really? So you can use Hadoop for batch data processing, or let's say you have large scale of data and you want to do some batch processing, go with Hadoop. Hadoop is the best fit for that. And log processing, that means reporting kind of stuff, session analysis. Okay, let's say in Facebook, from morning 6 o'clock to next day morning 6 o'clock, how the trend is going on. From morning 6 to 9, the flow is somewhat picking up. From morning 9 to 10, it picks up at higher speed. And from 10 to 12, people are working, then it goes to somewhat okay. Then from 12 to 3, again it goes okay. Then from 3 to evening 5, yes, it was running somewhat, the bandwidth of the traffic is much lesser. Again from 5 to 10, it starts picking up. Then from 10 to morning 6, it was running somewhat slow. So we analyze the data that is continuously appending at your application. So the session analysis, understanding the trend of your traffic, and building dictionaries, fraud detections if some fraud is happening, something like if some page you're trying to open and it will say 404 error, page not found, and sometimes it will say 500 internal server error. So how you're going to detect these kind of things, and how many user clicks, how many users are coming, and what people are clicking on what links, and what are the most things that they are looking for. This kind of processing, basically analyzing, you can develop with applications running on Hadoop, and building indexes as well. Let's say you search for something, and that's how you add your data to the search, and we index that data. So next, what are the most people are looking for? The first result will come as a first deck in Google. That's called ranking of your site. So site ranking we can do with Hadoop as well. And machine learning. Machine learning, let's take some concepts like, we use regularly some mailing, Google Mail, Yahoo Mail, Hotmail, AOL, we use these kind of mails. Without we do something, without a human intervention, some mails automatically categorize into spams. So your mail detects, your mail mechanism detects that, yes, this mail is a spam mail, let's move it to spam. So how it is, this kind of filtering kind of technology, we use it with Mahout, a programming called as Mahout. It's totally machine learning, which runs on Hadoop, absolutely, and another friend of Hadoop. So Mahout and R does this kind of prediction analysis, or else filter creations, or else filtering your data, automatic detections, these kind of things. So that's what machine learning. It's totally different concept from Hadoop. Alone Hadoop and some 5-6 other components you can learn in 3 months or 2 months. But machine learning, just Mahout, it just take times like around 6 months to 9 months. Machine learning is totally new concept. And let's talk about the different components what are involved in Hadoop. So let's take with the existing example. You write some query, something like select count of star from students table. That's one query. So how are we going to do? So there are involving basically 4 steps in that. One is it compiles your query. A query compiler will be there. It compiles your query to machine level language. Then your execution engine will come into picture. Of course, I am leaving some points which are not necessary at this point of time. So query compiler compiles your query to machine level language, and then execution engine generates the execution mechanism how to execute this query, and then it's going to run on your data, and then it's going to process your data or analyze your data and then use back your results. And again, query compiler will compile your results to the tabular format of human understandable language. So majorly we see 2 parts. One is the data has to be stored in somewhere. The second part is how the data is getting processed. So data processing and data storing, 2 key points, even if you take existing or the Hadoop. So to store your data, we have a file system called as Hadoop distributed file system. So which is modeled on Google file system. In year 2004, Doug Curtin brought this technology at Google, writing on a new paper called as MapReduce, a parallel processing computing distributing technology. And then he started his work at 2005 at Yahoo. Yahoo has hired him, and he started working on that. In 2006, Yahoo has built its first cluster with Hadoop, a testing cluster with 11 nodes. By the time I joined Yahoo in 2010, we have like around 12,000 node clusters. Then by the time I left Yahoo, we have like around 48,000 node clusters. Today Yahoo is having one of the biggest clusters in the world, like around 68,000 node clusters. We have nearly 70,000 node cluster we have, one of the biggest clusters. Of course, we have other clusters like testing clusters, staging clusters, other clusters as well. So this is what the production cluster is. So this cluster is very reliable, right? Because every time you add some file to the data HDFS, nothing but your storage, it automatically backups your data. So if you place students.txt, a new file, it automatically takes 3 backups of that, like block replica 1, replica 2, replica 3. And as it's a distributed file system, you have multiple machines, right? Any block can store in any machine. So even if one machine goes down, you have other replica in other machine, so that you don't have to lose your data. Your application runs just like normal as earlier. So, and it supports high bandwidth file system. The disk seek time here it is very low, because as I told you earlier, in NTFS FAT32, ext2 or ext3 or ext4, we have a block size of 128 KB. That's why just to open 5 MB file, it takes lots of time. The disk seek time is higher. But in case of HDFS, your block size is 64 MB, so that you can retrieve data faster. You don't have to read multiple blocks. You can read from just a single block, so that your bandwidth is much higher over here. And it is customizable. If you have data more than 4 petabyte, it is recommended that you have to change your block size from 64 MB to 128 MB. And you can change it to any higher amount, but not less than that. So you have high bandwidth file system where you can see some speeds like terabytes per second and petabytes per second. Okay, this is what storing part. Then we have the other part called as data processing. So in data processing part, we have 2 components as well. One is MapReduce and another one is BSP, bisynchronous processing. In 99% of the Hadoop applications, we use MapReduce, because most of the people in the world, they don't know there is some technology called as BSP. You can tell that out of 1 lakh people who are working on Hadoop, maximum 10 people can know this technology, BSP, bisynchronous processing technology. So most of the people uses MapReduce, because BSP has its own advantages, MapReduce has its own advantage. The main thing is MapReduce is written in Java, so that most of the people can adopt very easily. And BSP, it has totally different language. So MapReduce, again, it has taken from older language called as Lisp. In the year of Lisp, we used to use in years 95, 85, in between that period, 1985 and 1995. So from that language, we took a dialect or metaphor, that MapReduce metaphor, and then we developed this algorithm. So MapReduce is a processing framework, a distributed processing framework paradigm that processes the data which is already stored in your HDFS in key value pairs. So we'll see what is this key value in later things, but in key value usually I can say as of now, because again it's another big topic. So MapReduce is a processing part. Exactly, I can tell it's a replacement of execution engine in your SQL query. So when you write some query, your compiler compiles it, and then your execution engine generates an execution mechanism, and then it executes as per the mechanism, and then it gives you results back, and it compiles back, and then gives you results back to the console. But this execution engine is exactly MapReduce in Hadoop. So you are going to write the execution engine. That means there is nothing internally automatically converts into some other. Whatever you wrote or whatever you're going to write, that's going to run exactly on your data. So which decreases all the time that takes to query compiler as well as execution engine, this part own mechanism, and you can customize it like anything to run much faster. Then you can write this execution engine or MapReduce in any of the languages like Java, C, C++, Ruby, Perl, Python, Scala. You can write in all these languages. And goals of Hadoop. Yes, I'm building an application with Hadoop now. What are the different goals that I have to reach when I'm building an application with Hadoop? Your application has to be highly fault tolerant, because we run with commodity hardware here. We don't use like bigger machines like SAN and all. So these can fail at any point of time. So your cluster has to have the capability to handle this fault tolerant or to handle these issues very easily. So your application and cluster has to be a highly fault tolerant application. And you have to provide high throughput of data access. That means, let's take an example, kind of a YouTube kind of an application, where your videos are going to continuously stream, from continuously reading is going to happen from your YouTube databases. So this kind of things, like throughput has to be higher, the bandwidth has to be higher. So the streaming is totally different, because if you're using some Excel file, you retrieve that, it's gone. It comes to your local. But streaming is continuously out to request response from your YouTube kind of application, YouTube servers, and then you have to get continuously data access. So your cluster has to have the ability to give you high throughput. And then large files. There is one serious thing that you have to notice. When you work with Hadoop applications, the biggest files are never a problem for Hadoop. If your size of the file is like terabytes or petabytes, those are never a problem for Hadoop. But if you have 1 KB files like a million, that's going to be the biggest hiccup for Hadoop. Hadoop takes lots of time to process smaller sizes of files, and it's much performs much better if you have larger files. So you have usual typical file size as gigabytes, terabytes, or megabytes usually. If you see of your customers' data, so we usually have a good size of data, and so Hadoop has that capability. You have to make sure that it is capable of handle of any scalability. That means any size of the files you can handle very good. And Hadoop has to follow simple concurrency, which follows like write once, read many model, not write once, write many. For write once, write many, we have another components. So Hadoop has to have the simple coherency model, like something like this. So these are the different goals that you have to use when you're using Hadoop. And different ways of using. So how can I use this Hadoop now? How can I write an application using this Hadoop? Yes, if you are a Java programmer, you can adopt the MapReduce Java API and you can write. And Big, it's totally new language, a parallel processing or runtime language, data flow level language, you can call it as. It's much easier to write in Big. I think most of you have your LinkedIn accounts, right? In your LinkedIn, on the right top corner, or just below your sign off, you get some people who are connected. Like if we two are connected, X, if a person X and if a person Y is connected, X has a mutual friend, Y has a mutual friend. So how they're going getting the recommendation of the connection. That is written in Big. It's just 40 lines, I guess. And you're seeing that LinkedIn is not a very small application. It's a very bigger application using worldwide. So and it's running much, it's running very efficiently. That's what Big is capability of. And Hive, yes, if you're a person with from SQL background, you can adopt this technology much faster with Hive. And HBase, and then NoSQL. Not only SQL, we have lots more functionalities. If you take SQL, you have two capabilities. It's OLTP, one is OLAP. In OLAP, we have Hive, and for OLTP, we have HBase, Cassandra, React, MongoDB, Goldmart, Espresso, NeoDB, VoltDB, GraphDB, like that. Around 12 to 13, 14, you have NoSQLs available in the market today to provide you OLAP. And for OLAP, you have Hive. So it's not a single. So Hadoop is not a database. Hadoop is totally a new framework which provides an interface for your database kind of a thing, or data store kind of a thing. So that's what. And there are many more others. You can see them. I just mentioned 4. We have like around 117 as I told, and many people won't know that still there are 117. And who is using this Hadoop now? So organizations across the world, people are using for Hadoop for both research and production purposes as well. Yahoo, which is the main contributor of Hadoop, and Adobe, Facebook, Fox and Media, IBM, Baidu search engine, Last.fm, eBay, even Apple is using, New York Times and Rackspace. Lots of people, organizations across the world using for research and production purposes. So Hadoop, how is it Yahoo? One of the largest Hadoop user, and there are multiple grid clusters running with Hadoop within Yahoo. Current stats is like around 70,000 nodes, one of the biggest clusters in the world. Hadoop is running it. Supports all internal user community because Yahoo is a major contributors so far to Hadoop. And one simple application, let's take of Yahoo. It's called Search and Advertising Sciences. This is what the search assist. This is what the application I. You might have seen this as well. To build this application, usually with 3 years of log data Hadoop. So just to retrieve this data for some search result, before Hadoop we used to take time like around 26 days. And that program is done in C++ in the year 2009, I guess we did this. And it took like around 3 weeks to develop that program for us in C++. But after Hadoop, get the stat. It just took like 20 minutes to give the results, log analysis results, search assist results. And we wrote it in Python, which took like for 2 to 3 days. You can see almost the performance or the productivity is increased like anything. What you're doing in 3 weeks, you're doing it in 2 to 3 days. What you're getting in almost a month, you're getting in almost half an hour. So that's how easy if you adopt Hadoop. And Hadoop at Facebook, let's see how Facebook is using. Every day you'll get like around almost 2.5 billion content bytes per day, and you're seeing lots of things like status updates, wall posts, photos, videos, comments, and you get like around 2.7 billion likes per day, and 300 million photos are going to upload it every day, and 100 plus petabytes of the disk space is going up at the FB's largest cluster. And every 30 minutes we have to query like around 105 TB data. 30 minutes 105 TB data. So you can understand from that, which we are almost 60% of the Facebook employees knows working with Hive. So they wrote Hive actually, a SQL standard, SQL interface for Hadoop. And 70,000 queries are going to execute on these databases every day. And you have like around 500 terabytes of data existing every day into these databases. And you've seen Facebook is almost never down. It never went down. I've seen it like a couple of times so far, but I've never seen Google. Then Hadoop on Amazon is true. Yes, if you're running on Hadoop, you have to build your own clusters, starting from a single node, multi-node, 2 node, 3 node, 4 node, 5 node, like that. Hadoop has grown to 70,000 node cluster at Yahoo. But I want something to cluster administration or cluster installation much faster. So then Amazon gives you that capability. So you can build cluster here much faster. If you give there will be, if you log into Amazon Web Services and you tell me that yes, I need EC2 cluster, there will be a text box saying that enter how many clusters you want. Yes, I want 2 clusters. Okay. Per cluster, how many nodes? I want 8 nodes in one cluster. I want 12 nodes in another cluster. Yes. Click on create. Just create in maximum 2 minutes. That's it. And this is absolutely commercial thing. You have to pay like around 99 cents per hour. Every hour you have to pay 99 cents every time you use the cluster. And the one major difference when you talk about Hadoop and Hadoop at Amazon EC2 is, in Hadoop the data storage point is HDFS, but in Amazon storage it's S3. S3 is the thing which stores your data, just like your HDFS, nothing different. But Amazon has designed it on its own, so it has named it some other name. And brief about Apache Hadoop, it's an open source, multiple organization development community. So who is the primary contributor? Other companies like Facebook, Amazon, LinkedIn, eBay, Apple is also committing like anything, and various independent programmers. Even I am a member of Apache Software Foundation. I committed for Hadoop 0.17. It's like in year 2009 and 10, 0.17, 18, 19. I worked for development of 1.x, so as an independent programmer as well. And now I'm working with Facebook for developing Presto for later future releases. And I'm working for in Mobi in some other project for as an analytical component. So that's what the thing. And anyone can use this Hadoop for free because it's absolutely open source. And you can build your clusters and then you can use your Hadoop. Anyone can enhance Hadoop. That means if you see that yes, there is some bug in Hadoop, you can fix a bug. You can write you write a test for that. You submit the test case and write some document that briefly that yes, this is what this bug is, and this is when the bug is going to when you're going to face this bug. And this is a fix for that bug, and then commit it to Apache Software Foundation. In your next Hadoop release, your name is going to list that yes, so and so patch and then so and so bug is fixed by so and so developer. So that's how Hadoop you can enhance. So Hadoop software ecosystem. Let's talk about Hadoop ecosystem. As I told earlier, Hadoop alone can't do anything. It has many other friends who are working with Hadoop to help it to perform much better. A Big, which is developed by Yahoo. And I would like to, I missed a point I guess. Hadoop is basically, I told you, Doug Cutting has developed this technology in the year 2006 at production levels. So he was already the author of Nutch and Lucene as well. Lucene is his wife. Lucene is a search indexing thing. So Lucene is his wife, and he named the technology as with his name, Lucene. So when he shifted some Hadoop, that yellow toy elephant, to his son in Spanish he called that Hadoop. So that way, from then he started naming this technology as Hadoop. So Hadoop is an animal basically; it's an elephant, and then pig again, it's an animal which eats. So what is the basic feature of a pig? Pig animal. It can live anywhere, right? And it eats anything, and it runs slow because it's a fat animal, right? So that's what pig runs on any kind of data. That means pig works with structured, semi-structured, unstructured data. And then pig runs slow. Pig runs slow means you're dealing with the larger data sets. That's why pig runs slow. And it can live anywhere. With Hadoop it can work. Without Hadoop also it can work. It's an independent language as well. So that's what the pig, which is developed at Yahoo. And Hive, it is developed by Facebook, data warehousing framework on Hadoop, which gives a SQL kind of interface for your data. You can query your data with your just like your SQL queries, select star from table, select count of star. And there are some capabilities because Hive is not much matured as SQL. Because let's say when I started working with Hive 0.7, today Hive is 0.13 or 14, I guess. So when I work with 0.7, we don't have a rank function. Rank of some column which gives you values like 1, 2, 3, 4, 5, 6, right? So we don't have that function as well. We have to write our own UDF for that, user-defined function, and then you can use it. And we started. It's not matured, but it is matured enough so that if you don't have any other function or aggregated function, UDFs or UDTFs, transaction functions, you can write on your own and then you can use it. So it's not much problem. And HBase, it's again a table store laid on HDF, which gives you the capability of OLTP. Hive whereas gives us OLAP. Hive is for analytics engine, and HBase is for transaction processing. If you want to insert some 100 million records per second, you can use HBase. And similarly, Cassandra at the same level. Most of the people uses Cassandra, HBase according to their needs. When to use what, that's what the key thing is. But by the end of our sessions, I hope we'll get some idea that yes, when to use what. And MongoDB, it's again different NoSQL called as document store, and NeoDB is there, React is there, VoltDB is there, GraphDB is there, Voldemort is there, Espresso is there, lots of NoSQLs are there. And some other components like drill to retrieve your data much faster, developed by Mapper and committed to Apache. And Cascade is again kind of a core engine. You can say just like Stinger. This both works from the same platform. Stinger is developed by EMC Square, whereas Cascade is developed by Apache or Yahoo internally. And Impala, again, as I told, Hive or Hadoop technologies are like batch processing, right? So to make this real time, we have some more technologies like Impala, Stinger, cascading. We have Presto these days. Presto is the upcoming latest technology, where it can query like around 150 million rows in 0.07 seconds. You can see how fast it is across 11 node cluster with just 128 gigs RAM each, and which was like around 7 petabyte data. So that's what it is. So we have Presto as well. So okay, I'm already using some Oracle kind of a database in RDBMS in my current application, but I'm facing lots of hiccups with Oracle. Lots of things I need to solve. So how can I solve data problems with Oracle? Yes, you can add one more tier to your application, which makes your application as a 4-tier application. So behind Oracle, you can keep your Hadoop, and whatever the data hiccups you're getting, move the data to Hadoop to, RDBMS to Hadoop using a tool called as Scoop. Scoop is a tool which allows you to data transaction or data movement to and fro from Hadoop and to Hadoop from an RDBMS or to an RDBMS. So you process your data in Hadoop, get back into RDBMS and then use it. So that's how Scoop is. And Flume. So usually at servers usually generates. Let's take a very simple thing, Apache Tomcat. Apache Tomcat is a web JBoss server which runs your web application, and it gives you some log kind of stuff. And if you want to analyze your stuff, you want to move your data from server location to the Hadoop, right? So Flume is a component which allows or helps you to move your data from several locations to your Hadoop file systems, and then you can process it from there. Scribe is also a similar tool, but Flume is developed by Yahoo and Scribe is developed by Facebook. And similarly, we have workflow services. Yes, you have to schedule some jobs and you have to run some jobs serially or in some chain fashion or in some circular fashion. Yes, you can have other components like Askban, Uzi from Yahoo. Askban is from LinkedIn. Both are workflow services, but they have their own advantages as well. And other file systems. Along with HDFS, you can stay with Lucene and Notch and Solar. Notch is where it's like a crawler. It crawls your web and then saves your data. And Solar, it is actually Google is built on Solar engine. So which when you search for something, it will give you the time taken and how many results per page. This kind of indexing and retrieving Solar is going to be helpful. And Hadoop's data, okay, we wrote an application in some MapReduce job and then we got the data, but how a customer can view that, reporting or dashboard kind of stuff. We have multiple tools like Splunk, Tableau, Pento, ClickView, Burst, and if you want to write on your own, you can develop on your own HTML5 application as well. So this is the reporting tools as well that will have connectors already to plug the data of Hadoop. And these are the upcoming technologies. Most probably in next 5 to 7 years, you will see these technologies as booming technologies. Just like how we are talking about Hadoop today, you talk about these technologies maybe next couple of 3 years. It's not very far. So Scala, one more upcoming programming language, and it's much easier. You can write in very lesser lines of code when you compare to Java. And Storm, it's an in-memory processing real-time technology. You can process data without storing. So usually what happens with your RDBMS is you store your data and then you run some query over it, you analyze it, get out. But before storing your data, can you analyze your data? Yes, with Storm you are going to do that. You are going to analyze your data on the fly and then you are going to store the results and then retrieve. That's it. So the processing happens before storing the data. And then again Spark, one more in-memory processing technology, Pressure as well, graph technology. So whoever are selling this Hadoop, Apache, the main vendor, it's a free from Apache. You can download it from hadoop.apache.org/download, and you can install it on your machines and you can run it on your clusters. And Cloudera, yes, Cloudera is also a vendor of Hadoop. It gives you like around till 60 node cluster of Hadoop. It's free from Cloudera, but from 61st node you have to pay to Cloudera because then it becomes commercial. Then Hortonworks. Hortonworks again, we have a commercial, we have free as well, HDP. And Mapper, it's absolutely commercial. You have to pay buck or else you don't get Hadoop from Mapper. So Mapper is kind of a different from remaining all here because Mapper is written Hadoop in C and C++. And that's why Intel uses Mapper most of the time because Intel and NVIDIA or this kind of graphical or gaming kind of a technology which deals with the processors or processing, they write programming in very lower level language, assembly level. So whereas C and C++ most of the time. So that's why they adopt Mapper. And recently Intel in collaboration with Oracle has released one more distribution, but it's failed like anything. And we have one more distribution from EMC Square, named as Greenplum. Again, it's a failure. And we have from IBM Big Edge, I guess, that's a failure. And then Infosys has released one more thing, that's the biggest failure ever. So, but most of the customers, they want some support. These days they're moving with Hortonworks. Even I recommend Hortonworks. If you want to build something on your own, if you're a real skilled developer, or if you have some stuff that I can build something on my own, you can go with Apache. Absolutely, you can go with Apache. And there are continuous bug fixes happen. So if you're using some tools like GitHub or something like that, it's very handy for you to fix these bugs with your local Apache release. So that's how the Hadoop distributions are. And Hadoop ecosystem. This is how it looks vertically. So this is a data storage point where you store your all your data in HDFS. Again, this is splitted. Across multiple nodes. Let's say entire cluster with slave 1, slave 2, slave 3, slave 4. All the slaves share this HDFS. and then if you keep some file in HDFS means it can store any of these slaves, and it also keeps replicas. So, and the MapReduce as I told you, it's a data processing technology. So this is the query engine where you write your MapReduce job. You can write directly MapReduce job in your Java or C or C++ or Ruby, Perl, Python or Scala, and it directly runs on the data existing on the HDFS and then gives you results back. So this is for analytical. I told you, right, Hadoop is basically for batch processing. So the MapReduce jobs take some time to run because here we deal with a large amount of data. No, I want something like OLTP. Yes, we have HBase or Cassandra for that purpose, where you can insert 1,000,000 rows per second, where you can retrieve 1,000,000 rows per second, and where you can update 1,000,000 rows per second. That's what HBase is, or any NoSQL is capable of. And yes, I know SQL, then you can go for Hive. Again, Hive has its own compiler which compiles this SQL to MapReduce job, and then MapReduce job is going to run on HDFS, and it processes it here, and then it gives back data here. And Pig, again, its own language, Pig Latin. You can write your Pig script over here. It internally converts into MapReduce job. MapReduce job runs on HDFS, gives you data back to Pig. And if you have some existing RDBMS, you use Scoop to transfer data from here to here, and then you store it here, process it here with any of these, and then again you transfer that back to RDBMS using the Scoop. And you can connect from Hive to BI reporting, because BI reporting means always you need some data in tabular format, something like some rows and some columns. So, for example, like Splunk or Tableau or anything like this. So those BI tools have a Hive connector. You can connect to Hive and directly to your HBase, and you can retrieve it as just like SQL format. And ETL tools like Teradata has its connector, and these days came as T-SQL connector for Hadoop for Teradata. Informatica is not yet grown. That's why people are moving from Informatica and Vertica to Hadoop systems these days, because it's much commercially it's much cheaper and it's efficient technology as well. And so okay, we have lots of tech components that works with Hadoop now, like around 117. In this case, let's say we have around 5 or 6, but these are all individual components. You have to make them, or you have to keep them in a single box, right? So Zookeeper, basically Hadoop is an elephant, Pig is a pig, Hive is a group of birds, like that. These are all animals. Where do these animals live? In a zoo. And who keeps a zoo? That's a zookeeper. So zookeeper takes care of kind of a coordination services between all your components in your ecosystem, and it helps you to run a better ecosystem. Let's say if a component failed, that means it doesn't have to hurt the other component. That means there has to be a loose coupling between the components. So that is going to be delivered by a zookeeper. And this is from Cloudera. In case of Hortonworks, that is called Ambari. So Ambari is going to use for coordination services. And sometimes you want to keep secure data. So that's what Ambari is for. It's called serialization, deserialization data. So whenever, like let's say if I place you in front of a Japanese guy and you know English, that guy doesn't know English, he knows only Japanese. You need some translator, right? So whenever he says it in Japanese, you translate it back to English, and then you're going to tell it back in English, and this English person again replies, and then again you're going to converse it back to Japanese. That's how the communication happens. So once you save your data to HDFS with Arrow, it gets serialized, just a kind of a encrypting. So when you get, when you're reading the data, you have to serialize the key, then only it gets deserialized, and then you get the data. Kind of maintaining security for your data. So that's all. So we covered like what is big data, so how data is going to evolve, and from where we get the data, what kind of different companies generates this big data, and how to process this big data, what factors led us to evolve a new technology called Hadoop, and Hadoop features we have seen, Hadoop capabilities we have seen, what are the components of Hadoop we have seen, and then we have seen like different components that works with Hadoop we have seen, and who is using Hadoop and how they are using it, we have seen that. And this is all the vertical ecosystem architecture background, and you can understand how this simple ecosystem works. So if you have any questions, I'm ready to answer. So let's start to one by one. Yes, Nishant, are you there? Nishant, can you hear me? Your voice is somewhat breaking.
Yes. Yeah, I can hear you. Vidya, I don't have any questions at this point of time.
You don't have any questions?
No, I don't.
Okay, thank you.
Yep.
Prem, you there?
I think I just asked it. Yeah, I'm here. So I was going to ask you, if you're looking into Hadoop admin, then what are the tools that you need to master the most?
For Hadoop administrators, we use Ganglia, Nagios, Puppet, and Chef. So these are the different things that we use to maintain this cluster.
Okay, these. So when you say all these three tools, I mean, are they all doing the same functionality, or are they different in nature?
Your voice is breaking, I guess.
So when you're talking about all these three tools, right? I mean, are all these three doing the same stuff, or they're doing something different? What are their functionalities?
No. You're going to do the same stuff if you're running with Hadoop administration. Most of the companies, even Yahoo, uses internally Ganglia and Nagios. So there are no other tools. Recently, one more tool called as Cacti came in, CACTI. So Cacti people are using these days. They started using it. It's not well developed thing. That's what Cacti is. So
Okay,
we
so
use all of
okay. Sorry, what was them again? Can you repeat it for a bit?
I didn't get your question.
So what were the tools again? Can you repeat it? Yeah, I can hear you.
Okay, your voice is breaking. Yes.
So what are the tools again? Can you repeat it again?
Hello? You can type in over here in chat, I guess. Okay. And Sarvanan, you there? Okay. Okay, who is there? Hello?
Hello.
Yeah, who is this?
Yeah, this is Tashfik, and I have two questions. And it's like that. What is the current billing rate for Hadoop administrator, and what are the future aspect, or like what are the future demand of this Hadoop administrator?
Hadoop administrator is going to good because we have other technologies that are running with Hadoop, but Hadoop has to be there. Without Hadoop, these things cannot work. So Hadoop administration feature you can see up to next 7 or 8 years easily. And see, we are using SQL from past 20 years, and we are still using SQL. And this is a new technology, and everyone is moving forward to this. And at least I can say for 10 years, Hadoop is going to be there. And of course, without Hadoop, you're not going to incorporate any other technology. So administrations also, you have lots of future. Did I answer your question?
How is the current compensation is like? Hello? How is the current compensation is like for Hadoop administrator? The billing rate.
Right now, billing rates, I don't know. In US, I've seen it. AT&T is paying higher rates so far, like around $250 per hour. That's what the AT&T is paying to its developers. And admins, you can get up to 110, 120 billing rates, I guess. If you get into some good like State Farm is paying 110, and Monsanto is paying like around 90, I guess. That's the cheapest. And anyway, it is paying like around 200. That's the biggest one. Yeah, usual rates you can see up to 90 to 110, 150 like that. But you have less opportunities because you're administrators, right? Right now, to be telling very frankly, there are very there are very less people who can work on the development side as well as building the clusters. So there are people lot to write the technologies in Hadoop, but there are not many more people to develop applications in Hadoop. So that's what became the biggest problem, and that's why the ROI of Hadoop is much lesser. Return of investment is much lesser. So people are, companies are getting scared to use this technology. So if they didn't apply this well, that's it. Your project is lost, and whatever the efforts you keep in there are lost. So that's why they're getting scared later. But when compared to developer, administrator opportunities are much lesser. I see that in US.
Hello.
Yeah, hello.
Then as I told you now, I'm working as Oracle DBA. So it it will be good for me to switch to Hadoop and learn Hadoop as an
Yes,
administrator?
yes, you get that. It's absolutely an added advantage for you. If you're from SQL background, most of the people definitely want to move to Hadoop, and I'm seeing there are very less people in that area right now. Hello?
Yeah,
So how many hours? Sorry.
I didn't get you. Hello?
Sorry, I would like to know like how many hours of study is required to complete the Hadoop course, and is there any certification also for the Hadoop?
Okay, I'm going to tell you that. I'm going to tell you the course contents as well. So how much time it take, and how many hours we are going to spend in there, and how we are going to cover through. I'll make a note that I'll just share you. I don't know who has sent this question. Prem, I guess, right? Kakia and Puppet. Prem, I did answer to your question. And yeah, that's the thing. So what the things I'm going to cover in this training are like, so these are the things that I'm going to cover. It usually comes across like 48 hours entire session training. So where we need like introduction like around a couple of hours, and HDFS directly I jump in and give you a brief introduction about HDFS, how it is, and different features like in around 3 hours. And MapReduce an overview, because MapReduce is totally something like new for you. You cannot understand it that easily as well. So, and then we have a FS shell guide. How do we copy this using? Just like how you have Linux program, Linux commands. And the first thing is you have to know Linux here. Without Linux, you can't do anything over here. You cannot do simply anything. You can't move into A, B, C also here. So you have to know FS and Linux shell commands as well. And then we'll jump into Hive, because most of the people are very familiar to SQL standards. Right? So we install that Hive and we install Hadoop and how it takes. And then in-depth exercise of Hive with real data sets. So how we do play with Hive exercises. And with thrift servers in real time, how do you see that? And then Big, we install Big, and then we run some scripts, and then some exercises with the real-time data sets. And similarly, a NoSQL, HBase or Cassandra, that's your pick. I can deal with the both. How do you install HBase or Cassandra, and then hands-on, and then how do you do some coding with HBase? It's much easier to do coding. Basically, OLTP means you have 4 properties, right? Create, read, update, delete. That's crude operations. And then we have MapReduce. MapReduce is the somewhat most important topic of entire Hadoop. Where I'm going to deep dive of Hadoop for like MapReduce, what it is MapReduce, how it's going to done in like 5-hour session, and different programs. How do you have to write using Java with MapReduce, and how do you write with Python, and some basic application on that. And if you want Ruby MapReduce, I can tell you with Ruby MapReduce as well. That's like the ask. And some other components like in Cloudera, how do you do this? In Hortonworks, how do you do this? In Scoop, how do you do this? How do you install Scoop, and then how do you use the Scoop? How do you transfer data from RDBMS to Hadoop, Hadoop to RDBMS? And then how do you use Flume? How do you get data from a server through Flume, and how do you use this for analysis? and then RabbitMQ. RabbitMQ, you might have heard this, but I'm not sure. RabbitMQ is actually a message broker, which helps you to transfer some messages from one server to another server. Let's say at some machine, data is continuously producing, and you want to pick the data continuously to Hadoop, and then you want to analyze that data. So RabbitMQ is the one which acts like a broker between all of these, and then it transfers data from the machine where it's generating data to Hadoop, and then you can analyze it online. So that's what RabbitMQ, which is going to be an upcoming technology again. And Oozie, how do you do schedule of all this? Let's say you get your data from RDBMS, you get your data from Flume servers, you get your data from your RabbitMQ. Okay, combine all this data, store it in HDFS, and then run some program on that, run some data processing on that, and keep it in Hive, run some Hive queries on that, and then store the data, and then store the data back to HBase, make it available for real-time transactions. This is entire one workflow, right? So that is going to be hands-on by Oozie. So we are going to install Oozie, and we'll see hands-on with Oozie as well. And I'll take you through one application of my often personal. I can help you with that. And one real-time project, absolutely. This is for internal Hadoop ecosystem, that first one. And second one is with connecting the real-world application. I'll take you through 2 real-time projects in this. And I can help you with what frequently asked questions in interviews and what areas you have to be strong according to your expertise. Of course, if you're going to administrations, what areas you have to be expertise in. If you're going in as a developer, what areas you have to be strong in. If you're going as an analyst, what areas you have to be strong in. If you're going as a tester, Hadoop testing you might have not heard so far, but there is Hadoop testing. You do JUnit, MR unit like anything over here. Even I'll show what is MR unit and what is JUnit, how we use unit testing as well as other testing points in Hadoop. But that's what expertise how to get it here, and how can you crack the interview, the tips that can help you. And usually my sessions, like I take weekends for 3 hours, not continuous 3 hours. 3 hours means you get bored and then you can hang here and there. You absolutely can't concentrate for 3 hours, I guess. So we break into 1.5 hour session on weekend. And on weekdays we can schedule up to 2 hours. 2 hours is more than enough, I guess, because you two are most of the people, some of them are working, right? So I understand, because it's late night for you, and I work in totally EST and PDT timings, so it's not an issue for me. But if you can spend a couple of hours on weekdays and 3 hours on weekend, it will be very helpful for you, not for me. I won't get anything else. And my serious suggestion is, if you are seriously passionate about something, and if you want to build something that really matters, Hadoop is that technology. Hadoop can help you to bring you passion. And it's totally different new technology. You don't have to worry about that. The question is, if you don't have passion to bring into this technology, you don't have a longer run, simply. You cannot manage Hadoop if you don't have the passion. Because most of the times Hadoop won't give you the exact things what you're looking for. It's totally 99% real time, and you have to research a lot at almost all the times, because new components keeps on coming on, and what you have to use, when you have to use what, and what is what. These are lots of questions are there. Even many of the solution architects, they don't know what to use what in the current industries. I'm telling you, frankly, that's what's happening. So that's what the thing is. So if you're not seriously concentrating on Hadoop, please don't come to Hadoop and waste your time, because it might get you bored. Seriously, if you don't have the passion with you, you really get bored with Hadoop. And Hadoop has a great future, absolutely no doubt in that. Hadoop has a great future. So that's my final thing. So any other questions? I guess no. Hello?
Yeah. Yes, Sagar. Yeah. Let's wind up the session for today. If they have any questions, I'll get back to you on this, Vidya. Okay. One second. Sure. Yeah. Maybe what version of Hadoop will be in the lesson? Yeah. I think we have a question from Prem. You can check it out in the chat box, Vidya.
In chat box or in questions? Okay, let me see that. What version of Hadoop will be in the lesson? Okay, Apache, they are using Apache Hadoop 2.x.x. We can use that because that's the very latest one, and we built basically on single node clusters, and I can help you with installation on your clusters in your local machines as well. But I don't want to suck in with more times. I'll just take a overview and like I will install on my machine parallelly. You can see that how this guy is installing and how I can install. You can make a note of that because I can't wait for everyone to be done because there are lots of people in the session, right? So you can prepare on your own. But if you have some doubt, you can definitely get back to me. I will be there for that. So we are going to develop a single node cluster, and yes, I can help you with H as well, and yeah, I have my separate blog as well. If you really get stuck in somewhere with whatever the stuck you're in, just type it over in Google, you'll get my name. That's it. Very simple.
Okay, then Vidya, we'll wind up the session for today. Thanks for your time. Thanks for joining everyone. Nishant, Prem, Sarvanan, Tasveek, Yadgiri. Thanks for joining the call. Thank you very much.
Yeah, that's okay, Satish.
Thank you,
thanks
Vidya.
to everyone for the Thanks everyone for your time.
See you everyone soon. Thank you. Thank you very much. Yeah.
Yeah.